Hi, this is Bill Trombley from Trombley Tool in East Troy, Wisconsin. We have a new project in the shop. I got to make a gas tank and possibly two of them for a 1931 Curtiss Wright Travel Air 12W. It's a pre-war biplane. The fuel tank was mounted in the upper wings. Both tanks here, you could see in the background, are pretty well damaged. We looked at them to see could we salvage it, and it's just not cost effective. So I was thinking about maybe doing a YouTube video series on how I build the tanks. Some of it, because I'm going to be building it during the day, won't be able to maybe show all of it because we got the shop going with the guys and everything. We'd never get any quiet time for it. But I thought I could show maybe some of the aspects of it. Today what I did is I started laying out what little tooling I need for it. One of them is a wood form block for making the end bay ribs and also the baffles that go inside the tank. We have 3 tanks here and all 3 of them are different. And that's kind of common on the pre-war stuff. Standardization on some of that stuff really didn't start taking hold until World War II. One thing that we were kind of surprised with was the amount of damage to the tank. And I tested the material, and the tanks are built out of 1100 aluminum, which is no integrity to it whatsoever. It's very soft material. It was hard even just taking a portion of the tank apart. We had taken off the ends, the end caps on the tanks, and the stuff is just so soft. I was denting it up just trying to take it apart. So we decided the material was 50 thousandths thick, and World War II tanks from any of the manufacturers and then post-war were made out of 3003 by H14, so it's tempered material, and 50 thousandths, so we're going to stick with that. And then the internal baffles, instead of a 3000 series aluminum, we're going to go to a 5000 series. When we opened up these tanks, the ribs were broken inside, and the ribs where they're held in place, all of the fasteners were broken out as well. And you might be looking at that going, well, show us, and we're going to get there. We're going to get there. I thought what we could do though on this video was show some of the reform dies that I had to make. So what is a reform die? A reform die is like this piece here. So if you guys remember, I made this leading edge piece for the T6. We showed that in a couple other videos, and all I showed was the shaping of this section right here. I didn't show how I pushed this around. And what I did basically was I thumbnail die shrunk this edge, and then once I got past 90, I actually had to linear stretch this back out to get this to come around. But to get the cross-section profile, I used a reform die, and that is what this is. So this is made out of phenolic, and it's the inner and outer profile shape. And this goes in my trump machine, like this here. And this reform die is one of the dies that I made for this Travel Air gas tank. And you use a trump machine or a Pullmax machine or reciprocating machine because the stroke length is the same every single time. Not like a power hammer where that's variable. So this opens and closes and comes down to the same spot. And it takes and it corrects the form of the die. So the form of the part. So in the past we had talked about the difference between form and shape. So shape is me stretching or shrinking it. The form is how the panel is bent. Okay? So what do I mean by reform? Well, on this leading edge here, I stretched it in this area here, I shrunk it here, and I stretched it there as I was progressively building this piece To correct the profile, run through the die. If all of a sudden this didn't line up the way I want, I take the panel out of form, I add the shape where it needs it, then run it back through the die and then do it again. And you keep doing that until you get the finished piece. In this gas tank here, in these end caps, it has a funny bead profile. It's a pretty low profile bead, but it's wide and 1.25 inch radius, but this only sticks up 3/16 of an inch. Not very big. So I made the die out of plastic. Now I use plastic tooling, and a lot of guys will use steel tooling. Some guys even go with like steel tooling, like they think it's got to be tool steel, like S7 and A2 and all that stuff. If you're going to make your dies out of steel, cold 1018 cold rolled steel is just fine. You're never going to develop that kind of pressure. If you're doing a production tool, you know, where you're going to be running thousands of feet of material, could you consider S7 dies? Yeah. But if it was me and I was going to be running thousands of feet, I would never do the job in a Pullmax anyways. Think of these machines a little bit more for building prototypes than doing production runs. If I was shaping a steel part instead of aluminum part, would I build the dies out of steel? Yeah. The plastic tooling to maintain a hard, crisp line on corners and stuff like that, the tooling will tend to soften up over time. Is there tricks to that? Yes. Am I concerned about it? No. I mean, how much shaping do I do in steel? Extremely little. Mainly what I work in is either an aluminum or stainless steel. Look at stainless steel for hot section areas around jet aircraft. So I can get away with plastic tooling. What is phenolic? Phenolic is a fabric impregnated resin material that you can get in a board or sheet stock. Is it expensive? Yep. Where do I buy it? Facebook Marketplace. Then I'm not paying a lot of money for it. They're usually drops. Is there other plastics that work? Delrin would be the other one that I would recommend. Delrin is hard enough to maintain its shape, depending on how much pressure you apply to it, and that would be a white plastic. Is there other plastics? UHMW, to a certain extent, but gauge it this way. If you can take your fingernail and push your fingernail into the plastic, it's not going to have enough rigidity for running through a Pullmax machine or having it as the die in a Pullmax. It might work. Another one is polypropylene. That's like what milk jugs are made out of. Polypropylene won't have enough strength to it. What about Teflon? Some guys go, well, it's got to be slippery in Teflon. Teflon is extremely expensive and it won't have the strength to it. The die will just contort and twist to any of the point loads are. So I don't do that. Nylon. What about nylon? I'm an anti-nylon guy. And the reason why is we're a machine shop. And machining nylon is just a royal pain in the neck. It's very hard to break the chip. It's very hard to get a nice surface finish out of it. Nylon's an old material. And it's been getting more and more and more phased out of the industries, any of them. So you just don't generally see call-outs for it. It stuff's out there. Nylotron is another material. I find it humorous. You see guys go, I build my tools out of Nylotron. Nylotron is graphite impregnated nylon. It's graphite impregnated. The graphite's a lubricant. That's why it exists in the nylon. It's for bushing material. It looks neat. It looks all black and has this marbled finish through it. Still machines like crap. Sorry, it does. So I'm not a fan of it. I have some, and we've made bushings out of it because it was called for, but there's a unique reason why you would use it. So there's a number of these plastics that are out there. Best thing you do is experiment with it. You can buy plastic board stock material from Home Depot. It's recycled plastic. I've tried it. It doesn't hold its shape well. PVC does. PVC is a nice plastic, and you can buy that in sheet form. So there's a number of plastics out there. Why is plastic important? It's easy to cut, and it generally is tool mark free. You know, this leading edge skin here, you know, you don't see the hammer blows in it from the Pullmax tool. And you'll see it though if you went in major dies out of steel or aluminum. These were some aluminum reform dies. This is a joggle die I made. These were for making a door jamb on a Stinson L5. And there's two different profiles. The mating piece is in a box here on the table. And I made these out of aluminum because the panel that I was shaping was 4130 chromoly steel, 40 thousandths thick. So then, yeah, I went to an aluminum reform die. So it's something to think about. One of the other things that I do, people ask, you know, how do you get the geometry right? You know, because this profile is pounding that into the material. And how do you get it so you lay it out on there? That's easy. You got to remember, for us, I'm a machinist, so we use AutoCAD all the time. And what I do is I draw it in AutoCAD like that. You can see here how well that shows up. You can see my lines on there. And what we do is take a piece like this, draw the cross section. So what this rectangular square is with these 4 holes is my mounting fixture, how I hold my dies. And I use 1/4-inch bolts. That's what the 1/4-inch holes are for. And I save that as a template in my AutoCAD profile. Because what it does is it automatically shows me how big of a plastic block can I get in here as far as my shut height in the Pullmax. So that way I don't have to guess every time. And then I draw it in AutoCAD and print. Instead of print it, you can select a print feature where it prints it scale sizes 1:1. And what that means is if you draw it 1 inch, it prints it at 1 inch. Now the resolution on my printer, I think, is plus or minus a 1/2 thousandths. And I'll be damned if it isn't that close. You can take a caliper and measure the printed line, and it's that close. And we're building sheet metal parts. You know, so a couple thousandths of the thickness of a pencil line or the printer line. It's close enough for what we're building. If I needed to have more accuracy than that, then I could CNC machine it or machine it in the Bridgeport or whatever. If you notice here, I have the parallel lines of the upper and lower die. Right there. This would be the lower tool, and that'd be the lower tool. Now this material is 50 thousandths thick. The kerf of the bandsaw blade is about 50 thousandths. And I also use a scroll saw, electric scroll saw with a table on it. And those tools are inexpensive. And so all I got to do is keep the blade in between the lines. And once this is cut out, I have a male and a female. How do I fasten this to the material, to the phenolic? Spray can adhesive. So this is 3M Super 77. You get it from Home Depot. Probably any hardware store, if they're worth their salt, would have it on the shelf. So I just spray the back side of the paper and I stick it right onto the piece that I'm going to make and cut out like this. Now I got a line to follow, run it through the saw. Once it's cut out, then I take and I relieve off the corners. Like this here, you can see how I relieved this edge so that I don't get any edge bite when I'm feeding it through the die. and it gets this very clean looking result. But always run a test panel. So this is that gas tank and that bead profile. This bead profile parallels this outside edge. It's actually 1 inch in from here. So what I'm going to do is make this ribbed first by pounding this over the form block. So now this is 90 degrees before I put the bead in. Now that 90 degrees then hooks in this die here. And that's what this sample is, like this. So I'm going to tap the aluminum over the form block so I got it 90 degrees. And then that locates off of this edge here in the Pullmax die. And when that feeds through, this maintains this as being parallel. And this profile is correct. It's what I want. It's as straight as what the straight edge is here. This is 50 thousandths material. This is actually 6061 material. I'm building a tank out of 3003, but it was a piece of scrap that I had in the bin, and I always test it first. Now if you look here, you can see some die marks. Let's see. It's always, yeah, remember I'm looking at my cell phone. It's easier when you have this on a television. But right in the root here, there's a little bit of marking. You can almost hear it. And what that is the lower die has a corner on it. So I'll pull the die out, blend the corner, run the sample again until I get the result I want. And then I can go to town and build these tank ends. For this airplane here, we have 2 tank ends per tank, and we're going to build 1 tank, potentially 2. And then there's a couple of bead profiles here in this cross section of this tank here that you can see in there like that. And it's like a flat, and it tapers to a 45-degree angle on both sides, and it's a 1-inch flat. And that's used for where the tank straps go across to hold the tank in place. And so that's what the paper pattern is for the next reform die. And that's what that pattern is there. And that way it'll put in the same cross section, and I'll be able to do that in the truck machine as well. So that's how simple tooling can be made. If you're using a steel die, a steel upper and lower reform die, or even these aluminum dies, it becomes even more critical to test them. Because if you have a negative clearance in the die, in any one of the spots, you can develop enough power in a Pullmax machine, a Trump machine, any reciprocating style machine, where that negative clearance is actually pinching the material and thinning it, which is a stretch. So all of a sudden, you'll take the panel and you'll be running it through the die and the Pullmax, and the panel just warps and contorts and twists all over the place. And everyone's like, well, geez, you got a pre-stretch and all this stuff. Well, the pre-stretches or the stretch is occurring because of the negative clearance in the die. You're hammering in a thin spot. That stretch has to go somewhere, and that's what causes them to just corkscrew and lose control of it. So you got to take the negative clearance out. So you run a test panel, and if you see it's printing hard in the spot, you'll see it because it'll look shiny, and you'll actually see the individual blows of the machine. Blend the die out. Remove that negative contact spot. Also, too, when you run the dies closed, if the die is closed, you should be able to see that you have no pinch point. So another important thing is label the die. This here is a Tiger Moth, de Havilland Tiger Moth leading edge slat. I got a box here on my workbench that's full of these dies. And you're looking at it going, you go crazy, thumbing through the box and trying to find the male and the female die. So label the dies. Sharpie is great. I'm trying to come up with a system that's easy, like to tie these things together or something, so it makes it easier to pull them out. I was half tempted to even start writing them down like on a master list. I'm wondering how many of these dies have I made twice now, just because I didn't go digging deeper enough in the box to go find it. So, but it's something to think about. If you're not using an AutoCAD drawing or a drafting software, there's a lot of free drafting softwares out there where you can print the scale. If not, you're gonna have to use the old school paper method of a scale, a ruler, circle templates, and that kind of stuff. I still do a lot of that here as well, even though I got AutoCAD and a full CNC machine shop. Because I have a full CNC machine shop, why am I doing it this way? Well, that CNC machine's running all the time. To break that setup, to get these dies in there, I can do it, but it takes time. But I can also lay it out, piece of paper, spray can adhesive it to a piece of material, run through the bandsaw and get the same thing. I can do that a heck of a lot faster than I could ever get that in and out of the CNC machine. And for this stuff, it's just fine. So, and if you guys find this is interesting, we're gonna keep doing build videos on this particular gas tank. It's kind of a neat project. Is there shaping in it? It's all form. So there'll be some English wheel work with a rubber upper in this tank for forming some of the corners and the top work, and then some Pullmax die work. We're gonna be doing that to get these tanks knocked out. So we just hit 1,000 subscribers to the channel. For me, that's exciting. You look at some of the other shapers and they got, tens of thousands or 100,000s or whatever. But to get 1,000, that's pretty cool. So, and we're doing the best we can. Hope you guys like the content and that this stuff is interesting. One other thing you might look at and go, how did you know that you could make a material substitution for the airplane guys? What we did is we talked directly to the owners, and one of the owners is also an A&P mechanic, and he understands material strengths and all that kind of stuff. He also sees that that's the direction the industry went to during World War II. So we're making it equal to or greater than what it was. And ultimately, that decision lies on them as the owner, and the best I can do is give them as much evidence and advice as I can to show why we make the decisions that we do. So, but it's a decision that we feel is going in a safer direction. These airplanes don't have a lot of flight time on them, and these tanks are trashed because of it, and that's because of the amount of weight of fuel that's in there, sloshing back and forth, and it just kind of broke up the tanks from the inside out. So that was the reason how we came to that conclusion. So we'll have more videos coming here soon, and thanks for watching. Bye.